Today we're going to talk about solving proportions. You have worked with proportions in the past. To remind you what a proportion is, I have it written out here. It is an equation stating that two ratios or rates are equal. So 1/2 equals 2/4. That's a proportion. We've known that for a long time. Let's see what it looks like if we're dealing with quantities. So for example, let's say I have 7 girls for every 8 boys at the mixer. If I know that 16 boys are at the mixer, and I'm working with this rate of 7 to 8, how many girls are at the mixer? Well, 8 times 2 gives us 16, so we can just take 7 times 2 and get 14. So 7 to 8 is equal to 14 to 16. For simplicity's sake, you'll notice that in this proportion, I've kept the same units on top and the same units on bottom. I'm just pointing out that we are not multiplying these ratios. This is not dimensional analysis. So I'm not trying to put girls in the numerator and then girls in the denominator and cross-canceling the units. So please keep that in mind. With any proportion, it turns out that the cross product is always equal. You've also worked with cross products in the past, but I'll remind you of what they are. We can calculate the cross product by multiplying denominator by numerator. So 2 times 2 is 4. 4 times 1 is 4. So this is a proportion. And let's just make a note. Cross products in a proportion are equal. This will be very handy if we're trying to find missing values. Also, if we're just trying to figure out if two ratios happen to be proportional. So, for example, let's say I gave you 1/3 and 3/9, and I'm asking, are these proportional? Well, just by looking at them, you can see that they are in fact equal, because 1 times 3 is 3, and 3 times 3 is 9. You could also check the cross product. 9 times 1 is 9, 3 times 3 is 9, 9 equals 9. So a couple of different ways of looking at it, but in fact, yes, they're proportional. How about this example? Let's say we're taking a look at 1.2 over 4 and 2/5. Do these two ratios form a proportion? This one might be a little bit harder to figure out, so let's definitely use the cross product. 4 times 2 gives us 8. We have 5 times 1.2. Think 5 times 12. That's 60. 60 minutes, in an hour. We move the decimal back, we get 6. Does 6 equal 8? No. So here we have an example where the cross product, they're not equal, so we do not have a proportion. No proportion there. We can solve proportions for missing values. You will practice this as well. Again, lots of different ways to do this. I'll show you some neat tricks. It's always great to work as efficiently as possible. So for example, if I gave you 18 over 12 equals 24 over W, you already know that we have a proportion. Two ratios are equal. I could go ahead and start using the cross product to solve this. But I just want to point something out here. 18 over 12, can this be simplified? Absolutely. You can simplify individual ratios whenever you want. And if it makes the math a lot easier to do, and you can do it mentally, great. So what goes into 18 and 12? Well, 6. 6 goes into 18 3 times. 6 goes into 12 twice. So I'm just rewriting this in a simplified manner. Much easier. From here, there are a couple of different ways I could solve it. I can recognize that 3 times 8 gives me 24. So in turn, I can take 2 times 8 and find that W is equal to 16. Or I could use the cross product and set up an equation. An equation is very helpful when you don't have numbers that go into each other very easily, like this situation here. So I can set up the equation 3 times W equals 2 times 24. please make sure you have that equal sign in your equation. That's the whole point. Cross products are equal in a proportion. We know how to solve this equation. We can divide by 3. 2 times 24 gives us 48. 48 divided by 3 will give us 16. So a few different ways to solve. Just keep your eyes open with your numbers. Here's an example where a cross product is pretty helpful. Let's say I have the proportion 3/14 equals 15 over m minus 3. Now I would double star this one. This is a little bit trickier because we have to recognize what needs to happen with the order of operations before we go ahead and multiply across. I know I'm going to do 14 times 15, and I know it's going to equal 3 times whatever m minus 3 happens to be. But can I just leave it like this? No. I have to put parentheses in. The reason why is because as this is, we would do whatever's in the numerator and denominator first before multiplying, and I need to take this 3 and multiply it by the entire denominator of m minus 3. So we have to put those parentheses in. Lots of different ways to go about solving this. 14 times 15 will give us 210. We've practiced distributing. We could go ahead and distribute next. And then you have a two-step equation that you can solve. We undo the -9 by adding 9. And then we can go ahead and divide by 3. 3 goes into 21 7 times. 3 goes into 9 3 times. So it turns out that m, our missing value, is equal to 73. Please don't write 70. I know that 73 minus 3 is 70, but I'm not asking you what the denominator is equal to. I'm asking you to solve for the missing variable. And in this case, the variable m is equal to 73. And you can check it. Please go ahead and try this one on your own. That is a 2. Hit pause, and then when you're all set, hit unpause. Okay, so if we're checking this one here and we multiply across, so 2 times 1.4 should equal 5 times the sum of z and 3. We can go ahead and solve this. You should get z equaling negative, depends on how you did it, but -2 and 11/25, or if you solved it with decimals, -2 and 44/100. Okay, let's go ahead and see how we can set up a proportion given a real-world situation. So, let's say you are at a theme park and you are waiting in line to ride a pretty cool roller coaster. People do work on these things. When you're at Disney World, they have, different video monitors as you're waiting online, or different things to look at so that you're not bogged down by the fact that you might end up waiting an hour or more to ride a ride. Let's say this one theme park, the wait time to ride a roller coaster is 20 minutes when 160 people are in line. So it's 20 minutes when 160 people are in line. And I want to know that at this rate, how long is the wait time when there are 220 people in line? So we could write a proportion and use the cross product to solve it. And I will tell you there are many correct proportions. First, let's just get down the rate. You could write 20 minutes per 160 people like this. Okay, or we could do it another way. I'll show you in just a moment. Okay. And what I'm trying to do is find the amount of time, so that would be x minutes, given the fact that I have 220 people. Going back to what I said initially, to keep it simple, I have the same units on top. I'm comparing minutes to minutes, and the same units in the denominator, people to people. So I'm just throwing that out there. Keep that in mind. this proportion could definitely work for us, and you don't have to have the units when you are solving, but I wanted you to make sure you understood what I was doing. I said that's one correct proportion. Another correct proportion is this. Let's say I had 160 people to 20 minutes. And if I have 220 people, you know, how much time will it take? I can just use X. So here I can solve the proportion 160 over 20 to 220 over X. You'll notice that it doesn't matter which equation you end up going with, because when you find the cross product for both of them, you will get 160 times X equals 20 times 220. Go ahead and solve this, and then or hit pause and solve it, and then hit unpause when you're ready to see the solution. Okay, so when you go ahead and solve and balance, you will get a wait time of almost a half hour. 27.5 minutes. Let's talk about another situation. A lot of teachers are runners, and they run different races. Some run marathons. Let's say that we have a teacher who is planning on running a 13.1 mile half marathon. So 13.1 mile half marathon. That's very far. And she tells of her plans to her European friend, who asks how many meters she'll end up running. Well, I'm going to tell you that there are approximately 1,609 meters in 1 mile. I could use the about symbol. Okay. And we want to write a proportion that could be used to find the distance of the marathon in meters, of this half marathon, I should say. So let's use the rate that we're given here. We know 1 mile is to 1,609 meters. Okay. And I know that the half marathon is 13.1 miles to X meters. That's what we are unsure of. This is one possible proportion. You could have started with this. We don't know how many meters 13.1 miles happens to be, but we do know that there are 1,609 meters in 1 mile. Okay, here's another example. I could do this a couple of more times. Again, I'm just pointing this out, that there are many, many different proportions that you can set up that would be correct and would get you the solution needed. We are also going to practice writing equations of the form y equals kx a little bit more. But again, in this section, I believe you'll be asked to use different variables other than y and x. That's okay. So let's talk about money. So in 4 weeks, Marley earned $550 at her job. Write an equation relating the number of weeks, W, to the number of dollars, D. And at this rate, how many weeks would it take Marley to earn $5,000? Already, I'm sure the wheels are spinning. There are so many different ways we can solve this. But we do want to set up an equation of the form y equals kx. So let's think about that process again, which we've been practicing. So step 1, we need a unit rate. I know Marley makes $550 in 4 weeks. So let's go ahead and divide by 4, and let's get that unit rate k of $137.50 in 1 week. Now, what are we trying to calculate here? Well, we're trying to calculate how much money ultimately she earns given the number of weeks. So that's like my y, and this is like my x. So y equals my unit rate k times x, or using the variables given, d equals 137.50 times x. Oops, I meant w. Either equation would be fine, but this is using the variables given. Now, we want to know how many weeks it will take Marley to earn $5,000. So I'm substituting the $5,000 in for dollars. When we go ahead and divide, we will need to round. we get about 37 weeks. See you next class. Thank you.